Hi, my name is Robert Feranek and I created this video for everyone who would like to learn how to use OrCad and Cadence Allegro. I created this video for young engineers, for students, for people who never use this software. But also I created this video for experienced engineers who used to work with different CAD software like Altium or Eagle or KiCad, and now they need to move to OrCad and Cadence. In this video, we will cover the complete design process of a simple board. So you understand the workflow, you understand how these two softwares are connected together, and you also learn all the steps which you just need to know to create basically any board in OrCad and Cadence Allegro. We will start with creating libraries, schematic symbol libraries. These are the three components which we will use in this example. So you will learn how to create any schematic symbol, then you can create any board. We will draw a simple schematic where we will use these schematic symbols. We will speak about path editor, why we need to use it. We will speak about how to create footprints, the physical representation of the components, and then we will use the footprints in our board. So you will learn how to create a board in Cadence Allegro and how to do very simple layout. We will connect all the components together. Once we create the board, you will also learn how to print some documentation. So for example, how to print the layout into PDF or how to print the schematic into PDF, but you will also learn how to generate the Gerber files. These are the files which are needed by PCB house to manufacture your board. So as you can see, we will speak about all the important steps which you need to know to be able to use the OrCad and Cadence Allegro. Okay, let's do it. First, I'm going to open the OrCad. Click on Start, All Programs, Cadence Release, Allegro Products, Capture Sys. And I will select this OrCad PCB Designer Professional. Click on File, New, Project, name the project, select Schematic, and choose the location where your project is. Okay. I'm going to rename the schematic page, right click, rename, let, and also I'm going to rename this directory, right click, rename, we are going to create library, file, new, library, save the library inside our project directory, right click, save as, be sure you are in the project directory, and I will call it let, save, and we are going to create Resistor. Right click on the library, new part, Resistor. In future you can use part name here. For this demo I just use Resistor, and this is the prefix. Okay. If you cannot see this panel which is here, just go to View, Toolbar, and check this, Draw. I'm going to move it here so you can see what buttons I'm going to use. And we are going to place pins. Click here, pin name 1, pin number 1, okay, place, place. Press Escape. I'm going to show lines as the grid, Option, Preferences, Grid Display, Lines. I'm going to switch off the snapping to grid because I would like to draw between the grid points and use this, place line. If you would like to zoom in, press Ctrl, hold it down and use mouse wheel. Now just use the left mouse button, click and put it somewhere into middle of the square. Click, 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 click. Almost done. Press escape. Click on options, part properties, and we don't want to see the pin names, so I select this false, and we don't want to see pin numbers, false. Okay. Enable the snapping to grid again and just move this resistor shape. Save. Go back to our library, right click, new part. We are going to create LED. Prefix is D, okay. Place pin, cathode, pin number 1. Escape, double click, anode, okay. This is very important. Remember, pin number 1 is cathode. We will use it then in footprints. I'm going to make some space. Switch off the snapping to grid, click on line, press Ctrl and mouse wheel, zoom in and draw the diode symbol. Click here, click, hold shift down and draw the triangle. Escape, edit, properties, fill style, solid, okay. I'm just going to check if I draw it correctly. Okay, it is in line, and this one, it is in line, perfect. Now I'm going to create the small arrows. Click here, again press shift, hold it down, escape, edit, properties, solid, escape, press Ctrl, hold it down and select the whole arrow, move it a little bit, Ctrl C, Ctrl V, switch off this, place line, and also here, hide the pin name and pin number. Okay, zoom out and just change the shape of the diode. Okay, like this. Save. Only what is missing is the connector, so let's go back to our library, right click, new part, connector J, okay, this is going to be very quick, place pin, plus, number 1, escape, change this to minus, okay, draw rectangle and move this, save. In the next step we are going to create pins or paths which we will be using in our footprints, and also we are going to create via which we will be using during our layout. Click on Start, All Programs, Cadence Release, Product Utilities, PCB Editor Utilities, and start Path Stack Editor. Click on File, New, and this is very important. Be sure you are in the project directory. So I just go here, up, and go inside the LED project directory. First, we are going to create through hole pin. So I just call it through pin. Save. Be sure you select through pin here. OK. Change the units to millimeters and double check if it's this circle and through hole pin. Click on drill. This is the size of the hole in the through hole pin. It's going to be 1 millimeter. There is no change. Here select circle, 1 millimeter, no change. This is the path size. On the top and bottom we would like to have it circle and 2 millimeters. Just right click, copy, right click, paste, right click, paste. Mask layer, you know, it's the green color on your PCB, so we need to create hole in the mask around the path so we can solder it. Again, it's going to be circle and it's going to be a little bit bigger than the path, let's say 2.2 millimeter. It's going to be on the top and also on the bottom. No paste mask. Option, summary. File, save as. Be sure you are saving the through pin inside our project and save. Now we are going to create the SMD pin or SMD path. Click on File, New, select SMD pin. SMD pin. This pin is going to be used in our resistor footprint and in our LED footprint. Press OK. SMD pin rectangle millimeters. There is no hole. And the path size is going to be rectangle 0.7 by 1.3 millimeter. We would like to create mask around the path. It's going to be rectangle a little bit bigger than the path size, so 0.9 by 1.5 millimeter. And also we would like to create paste layer on the path. This is the layer which specifies where the solder is going to be placed for all the SMD components. Ideally, this size would be exactly the size of the path, but I would like to show you something, so I'm going to make it a little bit smaller than the path size. I'm going to make it 0.6 by 1.2 millimeter. Later we will change it, but you will see. No changes here, and this is OK. File, save. Only what is missing is the via, which we will be using during the layout. So let's create it. Click on File, New, select via, our via, OK, via circle millimeters. The hole size is going to be 0.2 millimeter. No changes here. This one is going to be 0.2. No changes. And you know, the path around the via is going to be circle 0.5 millimeter on the top layer and also on all the other layers. So right click, copy, right click, paste, right click, paste. There is no solder mask layer, there is no paste mask layer for the via. Leave this and just file, save. We are going to open the Cadence Allegro. Click on Start, All Programs, Cadence, Allegro Products, PCB Editor, and I will select this OrCad PCB Designer Professional. OK. Now we are going to create the resistor footprint. Click on File, New, click on Browse, and be sure you are inside the project directory. It's very important. Open, just call the footprint somehow. I'm going to call it resistor. This name is very important. We will use this name then in the schematic symbols, so remember it. Select package symbol wizard, OK. SMD discrete, next. Low template, next. Millimeters, and we are creating footprint for resistor. This is going to be 1.9 millimeter, this one is 2 millimeters, and this one is 1.25. If you wonder where I got these values, you will find them in datasheet and in recommended footprint. Okay. Next, here we are going to select the path which we created. SMD, enter this one. Next, finish. Tada! This is our resistor footprint. We are going to create the footprint for LED. Don't forget to save this. Click on File, New, LED, package symbol wizard. Okay. This footprint for now is going to be exactly the same as the resistor footprint. Later we will do some changes. We will mark where the cathode is, but for now just leave it exactly the same as the resistor. SMD discrete, next. Low template, next. This is going to be D, millimeters, 1.9 to 1.25, next. SMD, enter. Okay, next, finish. Yeah, it looks exactly the same as the resistor, it just uses D. And as I said, we will adjust this footprint a little bit later. Save. Yes. Only what is missing is the connector. So let's create it. File, New, connector, package symbol wizard. Okay. I will leave this. Next. Low template. Next. Millimeters. J. Next. 2. This is not important. This one is going to be 5. And I will change this a little bit. 9, 4. Next. Use our true pin which we created before. Next. I will use the symbol origin on the pin 1. Next. Finish. Save. We have the footprint, and what we need to do now is we need to assign these footprints to the schematic symbols which we created before. So go back to OrCad and double click on the connector, click on options, package properties, and put here the name of the footprint. To remember it? Connector. Do exactly same also for the resistor. And also for the LED. With LED, I would like to show you something. So what I'm going to do, I'm going to double click on this value and I will change it to, for example, I don't know, green LED. Go to your project and save everything. Finally, we can start drawing the schematic. This is the schematic page. Just double click here, and if you would like to zoom in, zoom out, press Ctrl on your keyboard and use mouse wheel like this. To place components into your schematic, use this button. Click. You will see this panel, and here is the library which we created, this one. Click, and these are our symbols inside this library. Click on the connector, double click, and click to place the connector into schematic. Press Escape. Now click on the resistor, double click, and press R on your keyboard to rotate the symbol. And just place it. Escape, click on LED, double click, press R to rotate, or you can use right click on your mouse and just select this, rotate, and click to place it. If you would like to move components which are already placed, you can just press the left button on your mouse, hold it down, and move the component. If you would like to connect the components, use this button, place wire, click, and just connect it. If you would like to interrupt drawing the line, press Escape. And if you would like to, for example, place a power symbol, go here, place power, double click, rename it. And if you would like to place ground symbol, just click on place, ground, and select this. If you would like to double check the name of the net, you can just hold cursor on the net. You will see it will appear the net name, or you can double click on the net. See, it's plus 5V. If I click on this one, it says GND. This one, it has a weird name, and I would like to change it. So what I'm going to do, I'm going to use this button, place net alias, click, and I'm going to call it, I don't know, diode. Okay, press R to rotate and place it on the wire. Okay, place it on the wire, it's important. Escape. Now if I double click on the wire, you will see it's called diode. When you are drawing a schematic, there are a couple of things which you really may want to know how to do. And one of these things is annotation. So I'm going to show you how you can reset the reference designators in OrCad and how you can annotate the schematic again. Remember the reference designators now, R1, D1, J1. Then go here, right click on the project, annotate, and select this, reset path references to question mark. Okay. Okay. What happened? What do you think? Have a look. All the reference designators now they have this question mark. R question mark, D question mark, J question mark. Now we are going to annotate the schematic again. So go here, right click on the project, annotate, select incremental reference update, OK, OK, and have a look on the schematic. R1, D1, J1, so it's correct now. The other thing, what you really may want to know how to do is how to change a symbol in library and then how to synchronize this change across all your schematic. And as an example, I'm going to use this LED, and let's say I made a mistake in the library, yeah, and it should not be green LED, this actually should be red LED. So what I'm going to do, I'm going inside my library. I will open the LED symbol and I will rename this. I will change it to red. Okay, go here, select the project, save everything. Now, what you need to do is very important. Here you can see design cache. These are the components which are used in our schematic. In the first step, we need to update this design cache. So this is the LED which we are using in the schematic. Right click on this LED and say update cache. This will update the cache from the library. Okay. And now what we would like to do, we would like to apply this change. We would like to apply this new LED symbol across all schematic, because if you go in our schematic page now, you can see the symbol, it is still green LED, it has not been changed. So what we need to do, we need to press right click on the LED and select this, replace cache. Go here, replace schematic part properties, and I will check this because I would like to keep the D1. Yeah. If you don't check this, all the symbols which will be replaced, the designator will be reset, so they will have the question mark. I would like to keep the reference designator, so I check it. Okay. Okay. Now, if you go into your schematic page, you will see the LED symbol was successfully updated, and now we have this red LED. Our schematic is ready, and you know all the most important information about how to draw schematic. So now you can draw schematic by yourself. Next, we are going to create a board. And for this, we will need to generate a netlist. Netlist will transfer the information from the schematic to our PCB. Click on your project, save it, click on your project again, click on Tools, and click on Create Netlist. We are going to create a new directory inside our project. It's going to be called Allegro, and there will be all the information about the netlist. If you like, you can also play with the settings which are here, but for now I just will leave it as it is. Okay, yes. Done. Go to Cadence Allegro, click on File, New, and we are going to create board. Let's call it LED. Okay. By default, the canvas is very small, so I'm going to make it a little bit bigger. Right click, Quick Utilities, Design Parameters. Click on Design, Units, Millimeter Size, A3. Okay. If you would like to zoom in and zoom out, just use mouse wheel. Yeah, watch here. And I'm using mouse wheel, see? Now I'm doing zoom in, zoom out. This is origin, and normally it's placed down here in the corner. I prefer to have it somewhere here in the middle, so I'm going to move it. Click on Setup, Change Origin, and I will move it somewhere up here. Click on Import, and we are going to import the netlist. Select Design Entry, find the directory where our netlist is. It is in the Allegro directory. Okay, import Cadence. Successfully completed. Now we can place the components. Place components manually. All of them. Here you should see all the components from your schematic. So place all of them and just move cursor on the canvas. You will see the components, and just press left button on your mouse to place the component. Once you are done, right click, done. Zoom in, press mouse wheel, and we can change the placement a little bit. So this is what is quite special about Cadence Allegro. First, we are going to select the action, what we are going to do. We are going to move components. So I click here, and now I'm going to select the items which I would like to move. So I will select this symbol, press left click on your mouse, and then just you can move it. If you would like to rotate the component, right click, rotate. Now it's going to rotate, see? So once you are happy with the rotation, left click, and you are back in the move mode, and if you press left click again, the component is placed. I'm going to do it again so you will remember it better. So left click, right click, rotate, left click, and just place it. Left click, right click, rotate, left click, left click. Once you are happy with the placement, press right click and select done. This will finish the move command. We are going to create the board outline. We are going to create the board shape. Click on add shape and select the layer where we are going to draw. Options, board geometry, design outline, type unfilled. Click on the origin and just draw the outline around the components. Zoom in, right click, done, and correct the position of the components. So use the move command, select them, hold the left mouse button down, select all the components, left click, move them, right click, done. Before we start doing layout, we are going to set up some basic rules, so you know how to do it because it's important. Click on this Constraint Manager button and wait a little bit. Click on Physical, All Layers, and we are going to change these default rules. We are going to change all the 0.127 value for, I don't know, 0.2, for example. So just click here and replace it. Click, replace, click, change it. Also, what we would like to change is this via, because if you remember, we specified our own via which we would like to use during the layout. So just click here, remove this default via, and double click on our via. Okay. Click on spacing, all layers. And this is a little bit unusual because here you can see 3 stars. This means there are some different values hidden in this line to column. Maybe you didn't notice, but here are these arrows. If you double click here, you will see much more values, much more columns, and you can see this column is different. Yeah. So these stars, it means there are different values hidden in these parameters. So I just make it smaller again, and I will simply just put there 0.2, and that's it. And also replace all these 0.2, 0.2, yeah, that's what we want. Click on the same net spacing and again change all of them, yeah, 0.2, 0.2, oops, I'm too quick. Okay, that's it. This Constraint Manager, it is quite a powerful tool, so later you may need to have a look and play with different settings. For now, it is just fine, yeah? It's important for you to know where you can set up the rules. If you would like to draw a track on your PCB, click on this button, Add Connect. Now watch this panel which is here, and this is important. The active layer is top layer. That's the layer where we are going to draw the track. Just click on a path and you can draw tracks. If you would like to change the width of the track, right click, options, line width, new, and I'm going to change it to 0.5 millimeter. Okay, left click on your mouse, left button, connect to path, left button, and here I'm not going to connect it here because I would like to show you how you can draw polygons and how you can place vias. So just click, press left button on your mouse, now right button on your mouse and add via. The via which will be used, you can see it here, it's our via. Yeah, so I just add via and right click, done. Now we need to draw the polygon on the bottom layer, so click here, shape, add. Be sure we are on the bottom layer and it's dynamic copper. Select the net, it's going to be ground net, and just simply draw the polygon. Right click, done. Now let's go through a couple of basic commands which you probably will need when you will be doing your own layout. So first, what you may want to do, you may want to adjust the shape of the polygon. Just click here, click on the polygon, and when you see this arrow, you can press left button on your mouse, hold it down, and you can move the edge, see? If you would like to just move part of the edge, like this one, this corner for example, just click and move it. Yeah, do not hold the mouse button, just move it. Again, click and move it. If you would like to add an edge, just click anywhere on the shape of the polygon, just click and move it. Yeah, do not hold the mouse button down. If you are not happy with the changes which you made, just right click and cancel. The other thing what you may want to do is, for example, you may want to add some text. Click on this ABC, select the layer where you would like to put the text, for example board, geometry and silk screen top. Set the size of the text. I'm going to put here 4 and just click somewhere, yeah, and I will put here plus and here I will put minus. Right click, done. We would like to move this text which we just added. I would like to move it somewhere here and here, and I would like to use a fine grid because now if I go here and I try to move it, see, it's just jumping around. So right click, done, right click with utilities, grids, and I'm going to change this 2.5. I will change it for 0.1. Press tab, 0.1. Okay, now if I try to move the text, click on move command and select the text, it's much smoother. See, I can just place it here and I click here and I just move it here. If you would like to move the text of the components, you need to use filter. Have a look. Now if I would like to try move only the text, it always selects all symbols. See, go here, find, select this off, and just check text. Basically you tell Cadence Allegro that you would like to work only with the text. So I check this, and now if I go here and move this, see, I can work with the text. So I zoom in a little bit. This R which is here, this is the silk screen top layer, so I would like to have it somewhere above the component. And this other R which is here, this is assembly drawing layer, so I would like to put it inside the component, maybe like this. Same here, this is the assembly layer, so I put it inside the component. This is the seal screen layer, I will put it somewhere here. This one is assembly drawing layer. Right click, rotate, left click, and also move this one. Right click, rotate, and place it somewhere here. Perfect. Save. The other command which may be very useful is the command which can move tracks. It is this button here. Click there. Just hover a cursor about the track which you would like to move. Use the left button on your mouse and just move it. If you would like to place components on the other side of the PCB, let's say we would like to move this R1 on the bottom side of the PCB, use the move command, select the component. Now we are selecting only this text, so we need to go here into the filter panel, all off, select symbol, because we would like to work with the components. Go and find the component which you would like to move on the other side of the PCB. Use left button on your mouse, right click, mirror. Now the component is on the other side of the PCB. See? Right click, cancel. It is very useful to know how to work with the layers in Cadence Allegro. You know, because there are quite a lot of layers, and during layout you will need to switch on and switch off between the layers quite often. So how to do it? Click on this visibility panel. Here you can see some of the layers, and here you can, for example, switch on or switch off these layers. This is the bottom layer, this is the top layer. But this is not all, yeah? If you would like to see and control all the layers, you need to go here, set up colors. This is a very important window. Here we are going to set up some views. A view is group of visible layers. And a little bit later, we will use these views to generate output documentation. So it's going to take a little bit of time, but we need to do it. The first view which we are going to set up is the top layer view. I will switch off all the layers. I will switch on the top layer, and I will also enable design outline layer. Okay, I'm going to save this view. Display, view, color view, save. Top layer. I will do same for bottom layer. Now I'm going to create the seal screen view. This is the layer, you know, which usually uses the white color, and these are the outlines around the components and the reference designators on your board. Now I'm going to create the solder mask top layer. This is the layer which specifies where the green color is going to be on your board, and it is a negative layer. So all the empty space is going to be the green color, and this, which you can see here, there is no green color. So there is no green color on the paths of the components. And also I'm going to create paste mask view. This is the layer where the solder is applied for SMD components. So here is SMD resistor, and we need to apply the solder on the pads to solder down the components. Oops, like this. Now, if you would like to see these views, you can just simply go here and select top layer or seal screen layer. It's very useful. Bottom layer. There are two more useful things about these layers. The first one is this small checkbox down here. Can you see it? Enable layer select mode. When I check it, then I can click on individual layers. And this is basically what is called like single layer mode. So you only see the layer where you click. This is the bottom layer. This is only the top layer. When I uncheck it, I can see again all the enabled layers. The second useful thing is sometimes you may want to see, or you may want to control other layers from this visibility panel. Let's say if you would like to control the seal screen layer directly from this visibility panel, I will enable the top layer, and we are going to add this seal screen on the panel. Click on setup, colors, find the seal screen layer. It is here. Right click here, add to visibility. Okay, now it is here. Can you see it? If I click here, you can see the seal screen layer around the components. You can disable it, you can enable it. Okay, now you know everything important about starting doing layout. So you can do layout by yourself and discover all the other features. What we still need to speak about is what if you need to make some changes in the paths which you created before, or what if you need to update footprint? How you are going to then synchronize these changes into your PCB? That's what we are going to do now. Open the path editor, click on File, Recent Path Stack, SMD Pin Path. Click on Mask Layers, and maybe you remember that when we were creating this paste mask layer, we made this rectangle a little bit smaller than it should be. So what we are going to do now, we are going to correct it. The size of this rectangle should be same as the size of the path, 0.7 by 1.3. So I go here, click here, and I will correct it. 0.7, 1.3. Now click somewhere else, because otherwise it will not remember the value which you changed. Save. And if you go into your board, you could update the paths here. If you click here, Tools, Path Stack, Refresh, that would update the paths in your board. But I don't want to do it right now. What I would like to do, I would like to go and open our resistor footprint, this one. I'm going to update the paths in the resistor footprint, and then we will update all board with the new footprints. So I zoom in, have a look. This is the paste layer. See, it is a little bit smaller than the real path. Click on Tools, Path Stack, Refresh. This is going to refresh the paths. Check it now. Can you see it? The paste layer is same size as the path. If I go here And if I switch it off, see, it is exactly same size as the path. Also, what I would like to do, I would like to update the seal screen layer, because at this moment this is the seal screen layer. I'm going to show you. Display, color, geometry, switch off, and seal screen top. Okay, so as you can see, this is the seal screen layer. This is the white line which should be around our resistor, and at this moment it just goes through the paths. So I don't want to have it this way. I'm going to redraw it. First I'm going to change the grid. Right click, grids, change it to 0.1, 0.1. Okay, click on this shape, add options, be sure you are in package geometry, seal screen top, shape fill, unfilled, and just draw the new seal screen layer around the resistor. Perfect. Right click, done. Now what we would like to do, we would like to delete this old seal screen. So I'm going to use delete command and use the filter, switch all off, only enable lines, and click on the old seal screen. Right click, done. Perfect. This is our new footprint for the resistor. Save. Doing any changes in the PCB library is very similar as doing changes in PCB. So for example, if you would like to update the shape, this is the seal screen which we just draw, you can use this tool, yeah, select the shape, and just you can make it a little bit bigger, yeah, here and here. I will save it. Now I will open LED. This is the LED footprint, and we are going to do exactly the same. So I will zoom in. You still can see the paste layer here. Click on Tools, Path Stack, refresh, refresh. Close, display, color visibility, geometry, all off, seal screen top. Okay, right click, grids, make it smaller. Click here. Be sure you are drawing on package, geometry, seal screen top, unfilled, and draw the new seal screen. What I would like to draw also is, I would like to mark where the pin 1 is located, where the cathode is located. It is here, yeah. I will close this. If you go here, and again, if you enable all the layers, you see this is the pin 1, yeah. So what I would like to do, I would like to mark the pin 1. So I will draw rectangle, package, geometry, seal screen top, and shape fill solid. So let's say I will make it like this. Perfect. Done. And delete the old seal screen. Click here. Find off. Lines. Select it. Right click. Done. Save. To make the seal screen a little bit nicer, what I'm going to do, I'm going to move this edge here, and I will save it again. Now we can go to our board, File, Let Board, click on Place, Update Symbols, select our symbols, you can see here they are, and just refresh. Close. Can you see? Oh, now the seal screen is around the components. I'm going to enable all the layers, setup, colors, and on. Okay, so you can see also here is the cutout, and we have now nice seal screen. Awesome. This is exactly what we wanted. We are ready to generate the manufacturing output and PDF documentation. Before you generate any manufacturing information, you always need to check if you connected all the nets and if all the polygons are updated correctly. You can do it here. Check design status, and all these, they should be green. Yeah, see, this is red, so I'm just going to update DRC. Awesome. Sometimes you need to update the shapes because sometimes they are out of date. So everything seems to be correct. Now we can generate the documentation. First, we are going to generate the Gerber files. These are the files which you need to send to a PCB house, and based on these files, they will manufacture your PCB. And it's very simple to do. Just click on this export and select Gerber. Now we are going to create the films. See, here are some available films, but we don't want to use this. We are going to create the films based on the views which we created. Have a look. I'm going to select this top layer view, press right click, add, top layer, and now we have new film. If you have a look inside this film, there are these layers enabled. These are exactly the same layers which we enabled in this view. Same way we can very quickly create all the other films. So I'm going to create the bottom layer, film, right click, add, bottom layer. Now paste mask, seal screen, and the solder mask layer. This is very important. Click on the film and set this undefined line width to 0.1. Do it for all of the films. 0.1, 0.1, 0.1, and 0.1. Now just check the films which you would like to generate and press create artwork. That's it. I open a Gerber viewer. I use this ViewMate so we can check what we just generated. File, import, Gerber. This is our project, and we generated these layers. This one, this one, this one, this one, and this one. import. I will switch off all the layers. So this is the bottom layer, this is the top layer, this is the solder, seal screen, and paste. Awesome. The next file, what we need to generate, is called drill file. Click on export, drill, and this file, it contains information about the holes on your PCB, about the position of the holes and the size of the holes. This is very important. Check this, click here, and also check this. Close. Now simply just press this button, drill. Successfully completed. To check the files, I will open the Gerber viewer again. I will select next layer, file, import, drill, and this is the drill file, import. If I switch off all the layer, and if you have a look on the drill file, this is what you will see. So we have 3 holes. Here is the via, and this is the connector. If I enable the top layer and the seal skin layer, you can see it, the via and the connector. In case you need to print your PCB or specific layers, I'm going to show you how you can do it. It's very simple. Just select the layers which you would like to print. For example, top layer. Click on File, Print Setup. This is what I use. Normally I print in scaling factor 1, black and white. File, Print. Set up the printer. I'm using PDF Creator. And just press OK. Name it. And save it. Yeah, this is the top layer and I just printed it into PDF. Very quickly, there are 2 more things what I would like to show you. First is how you can generate BOM, the list of all the components used in your schematic. Click on Project, Tools, Bill of Materials, open in Excel, OK. It takes a little bit of time, I'm not really sure why. OK, so you can see this is the list of all the components used in our schematic. And the second thing what I would like to show you is how to print schematic. Just select the project, File, Print, select the printer, I use PDF Creator again, and just press OK. Save, save, and it's done. I really hope you found this video useful, and if you like, have a look on my other videos. You can find them on Udemy or on my YouTube channel. Possibly have a look on my website where I teach about how to do hardware design. Thank you very much for watching and see you next time.